In this question, we are told that variables x and y are such that when y is plotted against x squared, a straight line graph passing through the points, and the points that we're talking about is 1, 3, and 4, 18 here are obtained. And something that we need to remember at this given point, this is a straight line, and so we can be able to say now, since this is a straight line, this is going to be given as in the form y equals to mx plus c, right? So which means that according to this equation, where we can say where y is representing what? Root y. You can say it's representing root y, and x is representing x squared. Now, in the process of finding the solution to this question, this is what we're going to do. We are going first, of course, to focus on the equation of the straight line that we've written, y equals to mx plus c. And on that regard, we are going to find the gradient. We're going to find the gradient of this line here. And we know that m represents gradient. And this gradient at this point is going to be obtained using these 2 points. So we can say 18 minus 3, 18 minus 3 over 4 minus 1. So this is going to translate to what? This is going to translate to 15 over 3, which is equivalent actually to 5. So the gradient of this line is 5. So the value of m here is 5. So which means y equals to 5 x plus c. Now, we can use any of the 2 points. We can even use this point, or we can use this point in order to find what the value of c is for this part, which is the y-intercept. So we're going to say now, using the point, which point are we saying? We're using the point, and the point we're saying is actually 1, 3. We can be able to find c using the point that to find c. So we are going to substitute where we have y, we shall write 3, and where we have x, we are going to write 1. And this is going to be 3 is equals to 5 into 1, then plus c, which will mean that this is 3 equals to 5 plus c, and this implies that our c is equals to 3 minus 5, and that means that this equation has the value of what? C value is actually equal to 2. Now we have the value of c and we have the value of m. So we can be able now to rewrite this equation, because we had said we are going to say that y is representing this part and this x is representing this part, and we have gotten the value of c as 2. So how can we write now the equation representing this? The equation connecting x and y is basically going to be written like this. Let me just calculate this point and ensure that of x, we are going to say, because this value of y is represented by this, we are going to write root y is equals to m, we got it to be 5, we got it 5 here, 5. Now instead of this x, we are going to write what that x represents. That x is representing x squared. So we say that is x squared, and the value of c plus c, our value of c is actually 2, like that. So this is the equation, and you can see now this is actually a nonlinear equation. So this is nonlinear. So we can see this is this equation is nonlinear. Yeah. So once it's linearized, that's when now you are able to get a straight line like that. Now in this question, we're told that x and y are such that y equals to a b raised to power x, where a and b are constants. The diagram shows, the diagram that we are referring that here, ln of y and ln of x, when they are drawn, they usually give, they are giving equation of a straight line. So meaning that this equation that was given here, that y is equals to a b raised to power x, can be linearized in order to give an equation with straight line. So in order to linearize this, we are going to find the natural log both sides so that we can be able to linearize it. This is going to be natural log of y equals to natural log of a b power x. But remember, when two numbers are multiplied and you have their logarithm, this can be written as ln of y is equals to ln of a plus ln of b raised to power x. And finally, we can be able to say that this power can go down, and we are going to say this is ln of y equals to ln of b x plus ln of a. So if you can be able to look at this equation that we have formed here, is an equation of a straight line, yeah, whereby this is going to be the y value, and this part here is x, but this is going to be mx. So ln of b is the gradient, and this is going to be the y-intercept. So from here, we can now say our equation y equals to mx plus c has been formed, where so we can say where y is actually ln of y, capital X is representing the small x variable that we are having at this given point, and we can now say our c is ln of a that we are having at this given point. So meaning the first thing that we are going to do in this particular question, we are going to find the values of m and c. We are going to find the values of m and c. Then they are going to enable us work out the value of a and the value of b. And how are we going to find the value of m and c? And now, since we are saying that m is the gradient, we can find m, which is the gradient. And this m, remember, a gradient of a straight line is going to be obtained by, we can call this our x2, y2, x1, y1. So remember, gradient of a straight line is given by y2 minus y1 over x2 minus x1 at that given point. So which will mean that this is going to be our y2 is 10 minus 4, 10 minus 4, and 10 minus 8, 8 minus 2, which will mean that this is going to be 6 over 6, and the gradient is going to be 1. So the gradient of this line that we're having here is 1. And what does that gradient represent? The gradient represents ln of b. From here, you see, we had related that. So we can say, therefore, ln of b is the gradient. So we can be able to say ln of b is equals to m, which is the gradient, which means that ln of b is actually 1. Able to express to index form, or we can be able to introduce e both sides. We can introduce, can say now, to find b, introduce e both sides. So we can say this e ln of b equals to e raised to power 1, and of course you can see that this and this will cancel out, and then this means that this implies that our b is equals to e raised to 1, which is actually e. That's the value of b. The next business that we have is now to find the value of a. And what's the value of a? A value of a is going to be related to the y-intercept. And in order to find this, we can be able to say this equation now, since we have the value of m, since we got the value of m to be 1, we can replace it in this equation that we have here. Okay, so that we can say this is y is equals to 1 x plus c, right? Then using one of these 2 points that were given here, we can say using 2, 4, we can find the value of c. Then we can now say this is going to be what? This is going to be 4 is equals to 1 times x, and our x in this case is 2 and our y is 4 here, then plus c. Then now from here you can see we are going to say our value of c is basically equal to 4 minus 2, which is actually equal to 2, as shown there. Once we have gotten the value of c to be 2, we can now say that c is equals to ln of a. Then we can say now ln a equals to 2. Then how can we be able to find a? We are going to introduce e both sides, meaning that we are going now to raise these two to e. Let me just work it out. So I'm going to work out this. Let me just make use of this page that is at the top here so that I can be able to show you exactly what we're supposed to do. So this is going to be ln of a raised to power e. So this is going to be e ln of a equals to e raised to power 2 as shown there. So which will mean that at this given point, e and ln will cancel out and we're going to remain with a is equals to e is to 2. So we have obtained the two constants a and b. And which are the steps you're going to follow in order to work out this question? We are going to go back and I'll show you what we did. We started by linearizing this, introducing ln both sides. We are going to have ln of y equals to ln a times b raised to power x. And since this is multiplication, then we can be able to add the two natural logs. Then now, if this is linearized, we are going to have a straight line which is y equals to mx plus c. Because on the y-axis, we are having ln of y, and on the x-axis, we are having this x here. Then we can say ln of y equals to ln of b x plus ln of a. And this represents the y. The ln of b represent the part of m, which is the gradient. So once we did that, we went ahead to work out the gradient of this straight line using these 2 points that we were given. And we got the gradient to be equal to 1. Now, once you get the gradient, because the gradient corresponds to ln of b, then we say now ln of b is equal to the gradient that we had obtained. So in order to solve for b, we are going to introduce e both sides. So, and we know when you have e ln of b like that, they cancel out and you're going to remain with b, and b is equals to e raised to 1, which is actually e. We got that. And once you have the value of the gradient again, you can be able to replace that, and this m now you replace it with the exact gradient that we got, and that value that we replaced is actually this one here. So y equals to 1x plus c. Now once we have this, we can now go back and use any of the 2 points in order to find the value of c. Once you get the value of c, you can now say that c, y-intercept, is corresponding to ln of a. Now the ln of a is equal to the intercept you got. We got 2 here. So we say ln of a is equals to 2. Now introduce again e both sides to get rid of ln. We got our answer to be equal to A is E is to power 2. If you have gotten value from Proflan YouTube channel, consider subscribing so that anytime we are going to upload further tutorials, you'll be notified. See you in the next video.